Can you explain question 6?
Question 6. Shortest carbon oxygen, that's referring to triple bond if there is any. If not, then it will be double bond, right? Because single bond is the longest, double bond is slightly shorter, triple bond is even shorter. So in this case, CO has triple bond. C shared 3 pairs of electron with oxygen, 1 pair of which is this pair comes from only oxygen, and then you have this, you have this. So carbon 1, 2, 3, 4, 5, 6, 7, 8, and then O has 1, 2, 3, 4. So actually carbon monoxide has 1 dative bond. Next, number 7, which of the following formulae is least likely to represent a natural compound? This is talking about the formula that is least stable, therefore cannot occur naturally. That means probably not octet, so that's one possible reason. C2H2 is a triple bond like that, so they are all the carbons follow octet rule. The hydrogen follow duplet rule, which means 2 electrons on the first shell. That's all they need, so that's stable. N has 5 valence electron, right? And each of these electrons form bonds with Cl. So that means if this happens, N ends up with 10 valence electrons, which is not octet, right? Not octet. Now, why is that impossible for nitrogen? Nitrogen is in period 2, so it only has S and P subshell. S can occupy 2 electrons, P can occupy 6 electrons, so in total it can only maximum occupy 8 electrons, right, in the second energy shell. So that's why having 10 valence electron is not natural for nitrogen. But for phosphorus is period 3. Period 3, phosphorus in period 3, so it has S, P, and D. Now, because of this D subshell, phosphorus can have extended octet, can have more than 8 valence electrons, but not for nitrogen. B is just talking about metal, so it's sodium, which is a metal. Sodium chloride is not a metal, it's an ionic compound.
Discuss 10.
10. So methane is talking about CH4 in liquid form. It's non-polar, so the type of intermolecular force is IDID. And it is tetrahedral, like that. So it cannot be metallic. Contains strong CH bond, yes, correct. All covalent bonds, ionic bonds, they are all strong. Some are stronger than the other, but in general, all chemical bonds are strong. It's the intermolecular force that's weak, right? So CH bond is a covalent bond, is a intramolecular, not inter. So it is strong. Tetrahedral is correct. Intermolecular force is correct, and it says here flows rapidly. Flows rapidly indicates that the methane molecules are not attracted strongly to each other, right? And it makes sense because we agree that it has IDID in the molecular force. Yeah. So, okay. Which statement explains the flow within the condensed methane? Yeah, the one that explains the flow is D. For liquid that are viscous, that means there is stronger intermolecular force. Number 11. In which following pair does the second substance have lower boiling point? Lower boiling point means weaker intermolecular force. So between F and Cl, they are non-polar. So the type of intermolecular force both are IDID. So IDID depends on the polarizability of the electron cloud. So the more number of electron, the more polarizable, because the electron cloud is larger. So the stronger the ID-ID. That's why for this pair, F is the lower boiling point. Okay. C is similar. C is both are non-polar, and C2H6 has less number of electron, so smaller electron cloud, less polarizability, and weaker in the molecular. All right, and B, this one is hydrogen bonding, and H2S is not hydrogen bonding. So for this pair, H2S is the one that has lower boiling point. It actually has PD. And D, this also is forming hydrogen bonding, right? So the one that has less boiling point is this one, lower boiling point. This CH3OCH, the structure looks like this. CH3, and lone pair there and here, right? So knowing that oxygen has higher electronegativity than carbon, so the shared pair of electrons are closer to O, so the net dipole moment points that way, right? This is the net dipole moment. So it's not polar. It is polar, right? So it is PD. It does not have OH or H bonded to O, so it cannot form hydrogen bonding, even though it has O, it has H, but the O and the H are not bonded together, so cannot have hydrogen bonding, right? Yeah, so answer is B. 12, boiling point of methane greater than helium. Both of them are non-polar, okay? Because if you're just one lone atom, then you cannot be polar. You're just by yourself. So everywhere the electron density is the same, right? Unless you get instantaneous or induced dipole. All right, so both are non-polar, so it's ID for both, and the strength depends on the electron cloud. Which in the molecular force in dry ice is a linear molecule, 180 degree, and even though the bonds are polar, so like that, but the dipoles of the bonds, the dipole moments, cancel each other because it's 180 degree of each other, right? So it's still nonpolar and it has ID. Van der Waals.
Miss.
So in 13, Van der Waals, remember that it can represent ID or PD, but dipole is always PD. Okay. 14, again, we want to see if the molecules are polar or nonpolar, and then what type of intermolecular force is the dominant one, right? The strongest one in the molecule. So this is non-polar, polar, and polar. Non-polar ID, very weak. Polar, and this is special because it has OH, so it's hydrogen bonding. And this one is PD. Guys, you have to remember that ID depends on the size of the electron cloud. So if let's say, right, you compare between, this is just like off topic, it's not about this question, but while we're at it, if you compare between C18H38, right, this is definitely ID because it's nonpolar, versus C2H5OH ethanol, this is hydrogen bonding, right? It doesn't always mean that the hydrogen bonding one will have higher boiling point. Doesn't always mean like that, because you see the electron cloud on 18 carbon and 38 hydrogen is huge, right? Compared to ethanol. So it's not a fair comparison. Okay, so it could possibly be that this actually has higher boiling point, right? Because of such large electron cloud. But in the exam, we will make it so that the number of electrons are quite similar with each other, so that you can pinpoint exactly which one has a higher boiling point. Okay, we will not give you questions that have unfair comparison, so to speak. Okay, now here we go back here. How do the boiling points compare? So the one with IDID are the lowest, and the one with hydrogen bonding is the highest. Next, yeah, the boiling point, account for the, okay, so the first compound, 1, 2, 3, 4, 5, 1, 2, yep, and this one is like that. It's highly branched, right? If it's a highly branched, they are actually isomers. They both have 5 carbon and 12 hydrogen. They're isomers of each other. But due to the branching here, so the surface area of contact between the electron clouds of the molecules is low, right? Or lower. So that means there is not a lot of polarization. Okay, less polarization, and therefore weaker IDID. Okay, so covalent bonds are equally strong, so this wrong. There is no hydrogen bonding. This one is correct, and this one is not, because both of them are nonpolar. So C is the answer. Okay, for this one, from the melting point, you can deduce the type of bonding as well. This is very low, so it should be simple covalent structure. And this one is quite high, so it's probably giant ionic lattice. Those are the structures. So deduce the type of bonding. AlF3 ionic covalent, and draw dot and cross. B has 3 valence electrons, and all 3 are bonded to F. So BF3 looks something like this, except I have to draw dot and cross. So you draw it using the circle thing, right? Like this, like this. Now, I think most of you got this correct, but the common mistake is that you forgot to draw the lone pairs on F. So never forget to draw the lone pairs like that. And AlF3 is ionic. So when you draw ionic compound, you have to use the square bracket. Now, aluminium loses 3 outer shell electrons, so it now has 8 valence electrons. So that's what we draw. And then you have to draw 3 fluoride, right? So you just write down big 3 like that. And this would be your fluoride. One of them has a cross, and the rest are just dots like that. Okay. Explain how the type of bonding present results in very different. Okay, so you say this has simple covalent structure and is nonpolar. So it has IDID intermolecular force. So it requires little energy to overcome. Whereas here is giant ionic lattice, and it has strong strong electrostatic force, between the cation and anion. So it requires a lot of energy to overcome. When you need to explain about the melting points or boiling points, please explain also the energy requirement. Boron trifluoride form a compound with ammonia. The type of bond is dative bond or covalent coordinate. And but you need to describe. So dative bond. So the description is the shared pair of electron between N and B come from nitrogen atom. Okay, so the equation BF3 and H3. Okay, some of you do it like this. BF3 dot NH3 or NH3 dot BF3 is fine. Or you can do it like this, F3B, and then you show that this is the dative bond. Yeah, but in the description, this is what you need to say. Yeah, so B dot and cross diagram, right? So please note that this shared pair of electron only come from nitrogen, so give them both crosses or dots, depending on what you assign nitrogen electron to be, right? H. And then here we have F. Oh, again, don't forget the lone pair of electrons on F, because F has lone pairs. So B should be the dot. That means F should be the cross for this case, and so on. Describe the type and nature of bonding. So type is metallic bond, and you describe metallic bond as a lattice of metal cations surrounded by valence electrons in the sea of electron, held together by strong electrostatic force. And whether it's a good conductor of electricity, yes, because of the free moving electrons or delocalized electrons. Done. This one, everyone is good. Name is triple bond or triple covalent bond. Triple bond is fine. Describe, you have to describe two nitrogen atoms share 3 pairs of electrons. Predict and explain. So this one, you can explain using the difference in the electronegativity values between magnesium and nitrogen, right? Difference in electronegativity value is more than 1.8. I don't remember what the numbers are, but if it's more than 1.8, then it's ionic. Write the electronic structure. Please do not write 2882 like the one that you did in IGCSE. This one you have to write 1s2, 2s2, and so on. Describe how atoms combine to form. Okay, so magnesium loses 2 electrons to form what? And nitrogen gains, each nitrogen gains 3 electrons to form what? N3 minus, right? N3 minus, and this is Mg2 plus. So together they become an Mg3 and 2. Yeah. The polarity of a bond depends on 2 things. The first one is difference in electronegativity, and the second one is also the length of the bond. Okay, so polarity means the separation of negative charge from the remaining. So if there is very short bond, the separation cannot be too much, right? Cannot separate too much if the bond is short. So the exception is CF. Even though F is a highly electronegative, in fact, it's the most electronegative element in the whole periodic table, but it's a very small atom. So the CF bond is very short. Compared to CCl bond, Cl is a great, like a larger atom, so the bond is also longer, right? So even though Cl is not as electronegative as F, due to the longer bond, there is greater separation of the shared pair of electron compared to, okay? So actually, it goes like that. So CH3F is slightly less polar than the chloromethane. And here you need to explain in terms of molecular geometry. So you say all of them are tetrahedral. So for CCl4, more electronegative atom is the chlorine, of course. But due to the symmetry, right, all dipole moments cancel each other. So the net dipole moment is 0. CH3Cl, so the net dipole moment is pointing to the Cl. Net dipole moment is not 0. And H3CF due to the short or the very short CF bond, less dipole moment, than CCl. So net dipole moment is still not zero, but it's also not as polar as chloromethane. So in the boxes below, draw diagrams to show the shape. This means you need to draw it in 3D because you need to show me the shape, right? You cannot just draw ammonia is like that because it actually doesn't look like that. You need to draw ammonia in 3D structure. So ammonium ion, that's NH4 plus. So the N has 4 hydrogen, 1, 2, like that, H, and don't forget the square bracket plus. So this one would be trigonal pyramidal, and this one is tetrahedral. You need to know the angles, right? 109.5, and this one is 107. Question 2. Since this is dot and cross, so you should have something like this, H cross, and the shape is, you can say bent or V shape. If they ask you for the angle, it'll be less than 109.5. Then this one is hydrogen bonding, and this one is PD. Okay, and then you talk about hydrogen bonding being stronger. It requires more energy to overcome. So A1, the angle is 120 because the geometry around carbon is trigonal planar, right? Carbon only has 3 electron domains, so it's trigonal planar, 120-degree, no lone pair. Draw a dot and cross diagram for hydrazine. So for each nitrogen, there is one bond to 1H, another bond to 1H, one single bond to N, and a lone pair. Okay, so around nitrogen, there are 4 electron domains around nitrogen, one lone pair, and then hydrogen, and what? And nitrogen, all right? And then same here, we have hydrogen, like that. So nitrogen has 4 electron domains with one lone pair. So this angle should be around 107 because it's N and H. So something with nitrogen, 4 electron domains with one lone pair is around 107, or you can say less than 109.5 because it's not exactly ammonia, right? Ammonia is 107 definitely. This one you can say 107 or 109.5. The melting boiling points of hydrogen are much higher than ethene, and it's because hydrogen has NH bond, so it can form hydrogen bonding, whereas ethene is nonpolar, so ID, okay, and then you talk about this being stronger, so it requires more energy to overcome. ID is weaker. Explain the with the aid of diagram showing lone pairs and dipole why hydrogen is very soluble in ethanol. Okay, so this is asking you to draw the hydrogen bonding, right? Because hydrogen can hydrogen bond with ethanol. That's why they can dissolve in each other. So and then we have oxygen from ethanol with the lone pair like that. And this is H, this is C2H5, okay? And then the hydrogen bonding looks like this. Please label hydrogen bonding and label the dipole, right? So this one is delta minus and this one is delta plus. And you also can draw over here, make the hydrogen bonding like linear. So this would be O, this would be CH2, CH3. Yeah. And then don't forget the dipole. Delta minus, delta plus. This is delta minus, delta minus. Yep, that is how you draw hydrogen bonding to show solubility.